All right, hello everyone. So today we have a multivariable calculus calc 3 question. Just we're finding the equation of the tangent plane at the point 3, 2, 1/2 on the surface x cubed e to the zy minus 1 equal to 27. Okay, so to do this, we're going to follow the following. So if you've got a level surface, f of x, you have a function f of x, y, z equal to some constant, and this makes up a surface. The equation of the tangent plane at that point, which is a point on the surface which satisfies f of x naught, y naught, z naught is c. And all I'm saying here basically is that if you look back at the equation and the equation, and you plug in the points 3, 2, 1/2 into the x cubed to e to the zy minus 1, if you plug in 3, 2, and 1/2, you're going to get 27 out of the whole thing. That's all this is saying, basically. So the tangent plane is given by what we have here in red, which says fx, x naught, y naught, z 0, z naught, times x minus x naught, plus fy, x naught, y naught, z naught, y times y minus y naught, plus fz, x naught, y naught, z naught, times z minus z naught equals 0. fx, fy, and fz all stand for the partials of my function capital F here, okay, with respect to x, y, and z. So what I need to do is I need to form that equation, basically. And the way that works is that you're going to take your function and you're going to take your partials. So with respect to x, y, and z. So if I find the one with respect to x, this is going to be 3x squared e to the zy minus 1. Fy would be x cubed times z e to the zy minus 1. Remember, with any one of these, but with fy here, y is the variable, x and z are the constants, so that's why that would work out. And yeah, I recommend that if you have a chance to please pause the video and try these partials yourself. For fz, we'd have x cubed times y e to the zy minus 1. So you start with your partials, and then what we're going to do is with each of our partials, we're going to plug in the point, which was 3, 2, 1/2. So for each of these partials, we're going to plug in the points. Let's see here. And we'll see what our result is right now. So we plug in 3, 2, 1/2, and fx, start with that one. You get 3 times 3 squared, which is 27, times e to the z times y, 1/2 times 2 is 1, 1 minus 1 is 0, so you get 27 e to the 0, which is 27. And likewise, this is what you'll get for the rest of the problems. You'd get 27 over 2 times e to the 0, or 27 over 2. And for fz, you would get 54. E to the 0, or just 54. So you'll take those points, and then you'll plug it into what I have written here, the equation, and you would take the values of your partial. So you would start with fx at the point 3, 2, 1/2, which was 27, times x minus the x value, which is 3, plus 27 over 2 times y minus 2, and last but not least, 54 times z minus 1/2. That would all equal 0. Now, you are obviously more than welcome to distribute the 27 halves, and the 54 respectively, and simplify this equation out, but I'll just leave it as is, okay? So that is how you go about finding the equation of a tangent plane to a surface. So in particular, this is with a surface. You also have equations of tangent planes as well. Sorry, I'm just scrolling up to see if I had written something, which I did not. But tangent planes to a graph. So what I'm saying is that you have z equals f of x, y, and you're asked to find the equation of a tangent plane at a point, x naught, y naught, but the idea here is that z itself is related to x and y, Well, if it is the case, this applies here as well, because you can make a level surface by taking f of x, y, and subtracting z here, and this would be your capital F of x, y, and z. And the only thing to note here is that fx would be the partial derivative of little f with respect to x. Capital F with respect to y would be little fy, and then finally capital Fz would be -1. And you would plug in your points in there, and the same result. You can use the same equation. So this equation is kind of multifaceted in that sense. Okay, well, I hope that helped. Thank you for your time.